Good morning, sir. Myself, I'm K. Rakshita from the Department of CSCE. Today, my data structure topic is about implementation of stacks using arrays with examples. Before digging into the implementation of stacks, let us know what actually stacks is all about. A stack is a linear data structure that follows the LIFO principle. LIFO is nothing but lastly inserted, firstly out. The stack is in the shape of a box in which one end is open and the another end is closed. The open end is known as top, where insertion and deletion of the stack is going to be done. Insertion of element into the stack is known as push, and deletion of element from the stack is known as pop. The most recent elements added to the stack is the first one is to be removed. Stack can be visualized as a collection of items stacked on a top of each other. So now let us see what are the characteristics of stacks. Stacks support two primary operations. Primary operations are nothing but the superior most operations which we do mostly. Those are push and pop. As we discussed previously, push is nothing but inserting an element into the stack, and pop is nothing but removing an element from the top of the stack. Now, applications of the stack. Applications are nothing but where the stacks are going to be implemented or used. Stacks are widely used in function call management in programming languages like programming languages like Python, C++ are the best examples, and data structures are the best example we could take. They are essential for undo mechanisms in applications such as text editors. Stacks are also used in praising expressions and syntax checking. Now, stacks operations. As we discussed in the previous file, push, pop are the major or primary things that we used in stacks, and another one is peek. Peek is nothing but which displays as the topmost element without any deleting. Push. Now let us see what actually push, pop and peek are actually about. This operation adds an element to the top of the stack. Pop, the operation remove the top element from the stack and returns it. Peek, the operation retrieves the top element without removing it from the stack. Now, stack implementation using arrays. An array, first, before going to implementation of stack using arrays, now let us know what actually arrays are. Arrays are the group of homogeneous type of elements which we gonna store some data or some data. These are represented by their index values. An array based stacks used to fix size arrays to store stack elements. The top of the stack is represented by an integer index that tracks the last added element. This implementation is allowed for efficient memory use and fast access. Push operation with example. Push is nothing but we're gonna insert few elements into the stack. To perform a push operation, increment the top index and the add element. For example, push the element 5 involves top plus plus. Here top plus plus means post increment, that is when the element is in already inserted into the array, the top is going to be incremented. If the top value is previously 0, when the top is incremented, now the top points to 1. I hope you understand. If the stack is full, an error message should indicate the push operation cannot proceed. Pop operation. The pop operation first check the stack is empty before removing the element. For example, to pop an element, return top of stack and decrement top. If the stack is empty, and message should indicate the pop operation cannot be proceed. Peek operation example. The peek operation allows you to view the top element without modifying the stack. The simple return stack top if the stack is not empty. If the stack is empty, an error message should be indicate the peeking is not possible. And here is the code in C++ where we could do push, pop and peek for a stack using arrays. Now, handling stack overflow and underflow. Overflow is nothing but when the stack is full. When the stack or array which is overflow, that is when we try to install the elements greater than the size of an array, then it is said to be overflow. Underflow means when there are zero elements or top is pointing to any unknown value, then it is known as underflow. Both conditions should be checked and handled with operating error messages. That is whenever if we try to print, if we try to get the message, we just need to do printf. In within the double close quotations, we have to keep the message that we has to be printed. Now, structure of stack implementation. Now, the stack can be defined with an array and an integer to top index. If top equal to -1 indicates the stack is initially empty. Initially means nothing but which is not the top, the element which is empty, that is we haven't did any operations. Now the top is -1. This indicates the stack is underflow. Now, advantages of array-based stacks. Array-based stacks offer constant time complexity for both push and pop. Constant time complexity, nothing but use the same time, doesn't offer any increment or decrement in the time. They use contiguous memory. Contiguous means nothing but continuous memory, which allocate, which means they have connection between previous one, which allows for better cost performance. This implement is similar and avoids the overhead associated with dynamic memory allocation. For which are the best examples of dynamic memory allocations, or malloc, cloc, and free are the best example that we could be discussed. And summary and conclusion, and this is going to be the last slide. We discuss about stacks or essential data structures for various applications in computer science. Implementing stacks using arrays provides essence, efficiency, and simplicity. Understanding stacks operations and their implementation is the fundamental for algorithm and design. Thank you.